Handwritten text detection using openCV and CNN. Abstract. The main aim of the project is handwritten text recognition, HTR. HTR is the task of transcribing images of handwritten text into the digital text. In HTR, the text is written, captured by a scanner, and then the resulting images are processed as input to return its text format. We need openCV and CNN for achieving this task. Our goal is to design a model that transcribes the images to text with great accuracy. Keywords: CNN, Handwritten Text Recognition, HTR, openCV, transcription. Introduction. Nowadays people have been using ebooks which do not occupy any space and ample copies can be carried comfortably. So there is a need for making more ebooks available. We have more number of handwritten texts available all over the world which need protection be safeguarded. By transcribing them we can increase the availability of ebooks. And also, instead of striving hard to protect old texts which are handwritten, they can be digitalized and stored as soft copies with ease. We will apply the machine learning techniques in order to find the digital form of handwritten text from their scanned images. We will take the help of the ready-made datasets that contain pixel values of scanned images as the inputs, and we will be able to find the text in it. We can also extend this project for different languages and writing styles. Problem statement: to accurately predict the text from a scanned handwritten text image using machine learning algorithms. For this we need to assume that all the images that contain same letters have same features, and we can conclude that an image having those features contains that alphabet. However, this hypothesis is ideal and may not come true always in practical. 2 data sets. The data plays a very important role in machine learning. The past data is used to predict the future outcome. The relevant data can be downloaded from the internet. The data that is related to our project, that is HTR, consists of pixel values. The format of the data files is CSV, separated values. Each row represents an image and contains a label in the first column and followed by 784 pixel values for 28x28 images. The data related to our project will have thousands of instances. The data that we use for our project is obtained from Kaggle. 2 types of data will be taken. One for English alphabets. A_Z handwritten data 1 and the other for digits, NIST dataset 2. Data visualization. For dataset _1 the shape will be 372,450, 785, and for dataset _2 the shape will be 42,785. A_Z handwritten data. The dataset will comprise of multivariate data of English alphabets. Here the dataset will have a label and pixel values which lie from 0 to 255. There will be total of 372,450 instances, and the total number of attributes is 784 in a label. 0_9 handwritten data. The dataset will comprise of multivariate data of digits from 0 to 9. Here the dataset will have a label and pixel values which lie from 0 to 255. There will be total of 42,000 instances, and the total number of attributes is 784 in a label. Fig 1. Bar diagram showing label sizes of different labels. Table 1. First 5 instances of the dataset. 3. Architecture. The problem: convert a handwritten text which is in the form of pixels into its digital form is a data-driven approach. The data which is already collected can be used for extracting the features of each letter. The availability of more powerful machine learning algorithms introduces an efficient and better approach to solve this problem. The project is divided into 2 modules. A segmentation module, in which an image is taken as input, letters are detected, bounded, cropped, resized and then segmented, and a training module where prediction occurs. The output of the segmentation module is the input of the training module. Fig 2. Architecture. For methodology. The research methodology in this project include visualizing and understanding the data, choosing a suitable model, agreeing on a common evaluation metric, Training and testing the models. Implementing the final model. Analyzing the result. Fig 3. Flow of training module. V. Experimental results. A. Segmentation module. Segmentation model is very important for this project as its output will be the input of the other module. 1. Read the image. We have many ML libraries like Pillow, openCV etc. for performing operations on images. Here openCV is used to read and manipulate images. An image is read and then stored in multiple copies for performing different operations. After reading, the image is plotted in its shape to make sure it is read perfectly. That image contains letters that need to be images, each cropped into 28x28 images by the end of segmentation model. Fig 4. An image of dimensions 351x232 pixels. 2. Detecting the letters. Object detection is a computer vision technique that detects certain components from in an image or a video. It makes use of machine learning and deep learning algorithms to yield good results. Detecting the letters is same as detecting objects. We need to apply some standard filters to the input image for achieving this task. Step 1. Convert a BGR image to grayscale image. An image with 3 channels is a BGR image, but a grayscale image consists of a single channel. A channel is a third dimension of an image. Fig 5. A grayscale image. Step 2. Applying Gaussian blur to the grayscale image. This step is done to remove any noise and disturbances in the image. If the image is blurred, the color intensities can be recognized easily from the image. The blurring is technically called Gaussian blur in the computer vision. Step 3. Otsu thresholding. A standard step for object detection. It is calculation of the measure of spread for the pixel levels each side of the threshold. Fig 6. Image after applying Otsu thresholding. Step 4. Finding and drawing contours. The find contours, and draw contours, are the methods used for finding and drawing contours, which are generally borders of a detected object in an image. The draw contours need image, detected contours, color, and dimensions of the border as the parameters. Fig 7. Image with contours. Step 5. Storing coordinates for rectangular bounding. Bounding rect gets the list of x, y coordinates of top left point of the image, width, and height, allowing us to draw images in the order of detected objects. We need to sort in the order of x coordinate of the top left corner to order them. All these lists are stored in a list and sorted with a base of list I0th elements. 3. Bounding and cropping. This part of code is added before cropping in order to add spaces between letters. In the list that contains bounding details, we add a space string if the distance between the corresponding x coordinates is 50 pixel values, representing they must be separated by a space. And then bounding and cropping for non-spaces and storing them in a list img_lst. The elements in the list of detected objects may be the bounding rect values of a detected object from the image or a space string. The detected object is considered a letter only if its height is greater than 20 pixels. Our assumption, then, for those which are considered letters, we use bounding rect values to crop the letter from another copy of the original image stored in another variable and append each of the cropped images which are in NumPy array form into a Python list. Rectangle draws a rectangular border around detected letters which has the image, bounding values, color, and width of the border. Fig 8. Image with rectangular bounds around. 7. Paint enter E. Fig 9. A cropped image of letter E is one of the results of cropping. 4. Resizing. For each cropped image in the list, we resize them to 28x28 pixels. We do so because the output images from this module, which are going to be the input of the other module, must be images of size 28x28 pixels, as the training data of that module is of that format. Fig 10. A resized image. Each resized images must be converted to grayscale to match requirements of training model, and then sent as input to the training model. The subplot of the output of segmentation module looks like B training module. A model is trained by using past data and machine learning algorithms. It learns from the past data by feature extraction and patterns. In this project, convolutional neural networks are used. We split the data into training and testing in the ratio of 80:20. The data frame with attributes, the data frame with only label column, train_size or test_size and shuffled are important parameter of train_test_split. Shuffled will be true by default, which shuffles the data before splitting. This method need not always return same output. Scikit-learn library is used to change the form of data. We need to convert the attribute values to the float data type and their labels into the categorical form to train them. The attribute values are converted to floating point numbers ranging from 0 to 1, which earlier were 0 to 255. A pixel value of 0 will be 0.0000, a pixel value of 1 will be 1.0000, and a pixel value of 128 will be 0.5000. Categorical form results in a list of size equals number of all possible labels, in which an instance with label value I will have I equals 1 and other elements 0. Even these values must be in float. The categorical form will look like this. Now we can proceed to train our data by using standard machine learning algorithms. A sequence of hidden layers are created with some nodes in each of them. The first hidden layer is two-dimensional convolution layer with kernel size 5x5 and 32 nodes. The activation function used is ReLU. And then max pooled with 2x2 and overfitting is reduced using dropout of 0.3. Then two more layers are added with 128 and n nodes respectively, where n is the number of possible outputs, here n equals 36. Now we compile the model by categorical_cross entropy loss function, atom optimizer with a metric of accuracy. Fig 11. Summary of the training model. The fitting of a model is shown below. It is passed with one iteration. 200 batch size and the dataset contains 331,560 instances. Model.fit, x_train, y_train. Validation_data equals x_test, y_test, epochs equals 1, batch_size equals 200, verbose equals 2. Instructions for updating. Use tf.cast instead. Train on 331,560 samples, validate Indiana 82890 samples. Epoch 1/1. 350s loss. 0.3029 ACC, 0.9184 val_loss, 0.1381 val_ACC, 0.962. 6 results. The above model will give us the train accuracy of 0.9184 and the test accuracy of 0.9626. Model accuracy. Neural network 0.1381. 0.9626. Army. Fig 12. Illustration. If HTR 7 challenges involved, I, letters like I and J which have break in them cannot be detected as a single letter. 2. If two letters touch each other, like in cursive writing, they are recognized as a single letter. The challenges we have faced while modeling handwritten text recognizer are: figure an image with rectangular border around detected contours. Figure a subplot for cropped images of above image. 8. Conclusion. Convolutional neural network learns from the real-time data and simplifies model by reducing the number of parameters and hence gives considerable accuracy. Future enhancements. We can increase the accuracy by taking huge datasets. By adopting much suitable algorithms. We can compile the model at more number of epochs. Hyperparameter tuning, there are a lot of parameters that we can play with. Use of deeper architectures. This application can be taken to next level by extending its scope to different writing styles. Extending its scope to different writing styles. Acknowledgement. We would like to acknowledge the help of Jainchua College of Engineering, Pulivandula for the kind support provided and our faculty and friends for the helpful discussions. We also would like to thank Kaggle who provided datasets.